All right, here we go. Video on. All right, you don't get my face in the corner like other videos. Never mind. No one knows what I'm talking about. Okay, so I got to get this out of the way. Let's put this over here. All right, so here's what you got to do first. Okay, and then I just told students that tomorrow we'll get the AP stuff. Today is focusing on what we talked about yesterday, graphing a quadratic. I'm going to yell at you, but I'm actually yelling at my last year students. We were mortified last year how awful the students were about graphing a quadratic, which makes me want to hit my head up against this wall. Because this is 100%, starts with an R and ends with a view. What is it? Review. I hope you jumped good. It's review. Okay, so everyone should know what this actually is, but I'm trying to refresh your memory. Number one, through yesterday's thing, this is vertex form. Opposite, same, so the vertex is 3 comma 2. Friday, you will have to fill out a chart of values. Input, say it. But yesterday, I showed you the 1-3-5 rule. So here's 3 comma 2. There that is as a coordinate. Then I am going to write, I don't know what that was. I'm going to write the 1-3-5 rule off to the side here. And then, and you can use it if you like it. All right. And if not, then you have to input, say it one more time. So here's a 1 in front of this. So that means it's going up. And the next set of points are up 1 and over 1, this way and this way. And I'm going to draw this right now. And get ready for this noise. Sha-na-na-na-na-na-na. That's our symmetry noise the rest of the year. That's the noise for symmetry. Okay, now I'm going to write this as well. X equals 3. This is called the axis of symmetry. It's a vertical line that cuts the graph in half so that I can use that sound to show the symmetrical relationship between these points. One more time, input, say it. Let's go ahead and do it the other way now, right in the middle of this question. I don't like that way, Mr. Samuelis. It's memorization, and I don't memorize well. That's fine. Then what you got to know is this is what you got to do. 3, 2, and 4. You plug in the 2 points right next to 3 and input, say it one more time. Hey, and let's tell the internet that there are students here. What happens if I plug in 4 here? What's 4 minus 3? Say it. 1. What's 1 squared? Say it. What's 1 plus 2? And by the way, what I just did there was PEMDAS. I did order of operations. Oops, forgot my D. What the heck is that? I don't love anyone. Oh, sorry. Did you hear that out loud? All right. Anyway, I love my kids. I don't know if they like me. I'm just kidding. Those teenagers, they always give me dirty looks when dad's in the house. How dare you be in the house that you built and pay for? Anyway, so I did parentheses, and then I did the subtraction in there, and then I did squaring, and then I did adding at the end. All right, it makes me sad how many people don't know how to do this. Last year. So anyway, wasn't that 4 comma 3, right? And then look at that. If you don't get that, if you don't get 4 comma 3 is right here and it's right here and that's a coordinate, there's a big problem. Huge. All right. And then what's 2 minus 3? Play along. What's 2 minus 3? -1. But what's a negative squared? 1. And then what's 1 plus 2 again? And then guess what? There's that symmetry. Got it? Okay. And then 5 and 1. I think 5 is a little easier because it's positive. What's 5 minus 3, everyone? 2. What's 2 squared, though? 4. What's 4 plus 2? I want to puke if I have students that cannot do these evaluations. Throw up all over you. That's not nice. I'll cut that out of the video. I won't. I'll leave it in. All right, so 5 comma 6. Oh, okay, now it's time for the... Oh, shut up. No. Rise 1, run 1. Rise 3, run 1. The next set of points would have been rise 5 and then run 1. That's the 1, 3, 5. Yesterday, the guy went 1, 3, 5, 7, 9, right? Didn't he show you all the way through there? All right, so that's how this works as well. Irregardless, if you do the 1, 3, 5 rule on Friday, you still have to, write those points down, okay? And then I still, well, I'll show you in the next example. Not really the next example, the third one. Okay, but now we'll go ahead and exercise this one, and we'll do a chart again. Now, I'm not writing the input-output when we're in vertex form. Opposite, same. So what? Oh, come on. I don't know why this happens. Oh, this technology. Okay, here we go. -3, comma, -4. And then look at this grid. -3, -4. Sometimes this is a clue. Oh, and by the way, the last one went by 2 or like halves, right? So you got to watch your scale. This one doesn't go by halves. Between -2 and -4 is -3. So I got to watch my scaling as well. You know, we messed around with 2 different coordinate planes there. All right, and then the 1-3, it's really the 1-3 rule because we don't really get to the 5th rule. On Friday, I'm going to have you graph 5 points. You have to have 5 discernible points. I had that in the last one. So 1-3 is good enough. But here's the problem. There's a -2 in front of this. So it's not 1-3. It's 1-3 times -2 is where our next points are. Again, you do not have to use this. Input, say it. You do have to do something, though, to get this graph. I'm trying to help those that can memorize. So that means we go down 2 and over 1, not down 1 and over 1, down 2 and over 1. -2 times 1 is our first move. Then our next move is -2 times 3. 1, 2, 3, 4, 5, 6, and then over 2. You know what? Let's get it over with. So we can do the noise. This is x equals -3 as the axis of symmetry. And then notice this is a, oh, I almost want to say skinnier, but stretch parabola. The word would be stretch on that. Okay, now hold on a minute. I don't like that. I'm going to do old school. Input, output. So I got to do -3, -2, -1. -4, -5, and then I'll prove that this works. Okay, it is a bit of a process, but let's plug in -2. It's easy though. Hey everyone, what's -2 plus 3? What's -2 plus 3? 1? You didn't answer, but you were in the middle of a sip. Your little Lockport latte. Is that Lockport or is that Starbucks? Well, I like Starbucks. All right, we got a little coffee shop here at Lockport. Very special place. -2 plus 3 is 1. What's 1 squared? What's 1 squared? 1. What's 1 times -2? -2 minus 4. I forgot what I plugged in. Was that -2? -6. -2. Well, I'll be darned. -6. See it? -2, -6. See? So this is why those people last year made me mad. It's one way or the other. I'm showing you 2 different ways to do something. You pick. And then go to -4. And just to make sure, what's -4 plus 3? What's -4 plus 3? I want to show this on the video. -4 plus 3 is -1, but what's -1 squared? What's 1 times -2? -2 minus 4 is yet again what? Get ready. It shows on the chart, and it also shows on the grid. And then I think we feel pretty good about this. Let's plug in 1 and then figure it out. Okay, let's do this again so you can follow along. I do not do, you are juniors and seniors. If you cannot input output, I am infinitely sad. What's -5 plus 3? What's -5 plus 3? -2, but what's -2 squared? 4, sorry. What's 4 times -2? -8 minus 4 is -12. Lo and behold, -5, -12. So this is going to be -12. Okay. What time is it? You know. Did the first bell ring? Oh no. Okay, here we go. Let's go to this one. You know what? We're going to annoy you. The opposite of b plus or minus. Does anyone else want to sing? The square root of b squared minus 4ac all over 2a. What is this called, everyone? The quadratic formula. Why did I write this up here? Because this is where I'm going to actually, like, here's where the plus is and here's where the minus is. That's, that's where the x-intercepts are, if they exist. If you get an I number in that quadratic formula, there would be no x-intercepts. Let's pretend. Then where did we say the vertex was? Right in the middle. So if you lop this off, that's the plus to the right and minus to the left, where the x-intercepts are compared to the vertex. So the vertex x value is negative b over 2a. The y value is, one more time, input, say it. This is input-output language. That's all that means there. So when I'm in standard form, I must know this formula. So why did I throw the quadratic formula up there? To have a connection. Have a connection between the quadratic formula and the vertex. And what the two actually represent. You know what I'm going to do? I'm going to do this chart like this. You can choose, I just want spatial differences here. So if you don't know what A, B, and C are, that's these. And then the opposite of it, I will tell you, I made a mistake first hour almost, and I caught myself. I forgot the opposite of B. So that's a negative negative over 2 times negative 2. So that's a positive 8 over negative 4, which is negative 2. And this is where you're going to stick it in the chart, right in the middle. Because it's the vertex where we have the symmetry left and right, so we can do our little sound. All right, one more time. I've said it a million times. Input, say it. So you plug in negative 2 for x to find the y. This is how you find any y. Again, infinitely sad students don't know this. Basic grade school graphing concept. The problem is, I think we go to like rules after this and then don't remember the basics. Say, okay, here we go. I'm going to grab the highlighter. What's negative 2 squared? What's negative 2 squared? PEMDAS. But what's 4 times negative 2? So let's write that one down. And then what's a negative times a negative? So that's 16, and we'll make that plus, and then minus 4. So this is 8 minus 4, which is 4. You do go in order left to right then to get that last part. Okay, then I'm going to go to my graph and go ahead and do negative 2, 1, 2, 3, 4. Now, if you want to do the 1, 3, 5 rule, but really stop at 3 because it goes off the scale, then it's the 1, 3, 5 times negative 2 rule. So this is going to go down 2 and over 1. This is going to be going down just like the last example I did. It's stretched. And then I'm going to go down, not 3, but 2 times 3. 1, 2, 3, 4, 5, 6. And you know what? Oh, here we go. Ready? Oh, wait, I lost myself. There we go. And then we got a nice little parabola like that. But you know what you really should plug in? It's simple. Fine. Negative 1, 0. Oh, how nice that is. When I plug in 0, look at this. Look at what happens when I plug in 0. 0 minus 4. What is the output value? When I plug in 0 for x, what do I get? Negative 4. That's the easiest one to check. Negative 4, and lo and behold, look at this. 0, negative 4 right there. So don't tell me you don't know how to do this. Don't tell me you don't know the 1, 3, 5 and I can't memorize it. Then do this. Input, output. Okay, and then because of, I'm done with inputting, outputting. No, I'm not, I guess. Let's just plug in negative 1. What's negative 1 squared, everyone? What's negative 1 squared? 1. What's 1 times negative 2, though? So I might want to write that. That's negative 2. And then what's negative 1 times negative 8? 8. And then minus 4. Negative 2 plus 8 is 6. 6 minus 4 is 2. Lo and behold, negative 1 comma 2. It's right there. You don't have to circle these. I'm just proving a point. And then I guarantee you, and I want to be done, when I plug in negative 3, I'll get 2. And when I plug in negative 4, I get negative 4 because of symmetry. But actually do it. I'm just shortening up the notes because I really should not have to be your teacher in that. You should know how to evaluate things. All right? All right, like I said, cross these off. Flip over your sheet to the other side. That's actually the homework. I don't want you to be confused on that. All righty.